Hello everyone, welcome to another short video on solving a LeetCode problem with APL. In the last video, that you can find linked to in the description, we solved this problem, 1365, how many numbers are smaller than the current number. And I noticed there's this similar questions tab, which, well, shows similar questions. And this one is, supposedly it's a hard problem, 315, count of smaller numbers after self. And it's very similar to the one we just solved, and so I thought that we could give it a go, even though we have been solving the easy problems first. And so what this says in here is that, sorry about that, we have this array of numbers and we have to return a new array of counts. And this array of counts is defined in such a way that each position of the counts array gives the amount of numbers that are smaller than the corresponding number to the right. Why can't I speak English? Basically what we are going to do is we are going to traverse this array of numbers, and for each number we look at its right and count the numbers that are smaller. That's what I want to say. So here, looking at the 5, so we are at the 5, we look to its right, there's the 2, the 6, and the 1, so only two numbers here are smaller than 5, and that's why there's the 2 there. And for example, if we look at the 6, to its right, there's only one number smaller than 6, and that's why there's a 1 in here. So this is what we want to do, and like I said, it's similar to the other problem we solved. And for the other problem, we had this vector, let's do it, so 5, 2, 6, 1. And for the other problem, the solution was this. We have an outer product. And the key here is the outer product doing all the comparisons for us. Now, if we look at, for example, this row looks at 6, at the number 6, because it's the third row, so it's the third element of V. Looks at the 6 and checks for which numbers 6 is greater than the elements of V. And we see here this corresponds to the 5, this corresponds to the number 2, and this corresponds to the number 1. But the problem is these numbers, these ones, they correspond to numbers that are to the left of 6, so we do not want to take them into account. And so what we can do is build a Boolean mask to remove these that we do not care about. And this Boolean mask with this pattern, this is really easy to create, and it's something I've been using a lot lately, and it's also with an outer product with one of the comparisons. So you just pick the correct one for your situation, and then you do an iota with the tally of V, and you can see here that this builds a triangular matrix. So there's ones in here above the diagonal, and we can take this and we can multiply it with this matrix over here. And what this will do, this multiplication here, or if you prefer, you can make it a logical AND. What this does here is it only allows for numbers that are, it only finds occurrences of numbers that are greater than and that are also to the right of the actual numbers. So we can do this, and we can see that the ones over here, these were like this, they disappeared because they were masked out by this. And then what we do is we sum across the rows again, and we can see here 2, 1, 1, 0. This is the solution for this. And the other test cases here are really not that good, so but we can show it works. So if we run this again, there's the 0, 0 that we would expect. So we can see here how we took a fairly simple solution that was this outer product and this summation, and then we just patched it, fixed it, so that we only took into account the actual intermediate results that we care about. So we can look at this outer product as computing a bunch of intermediate results, and then we use a Boolean mask to filter out the ones that we do not care about. So this is a fairly common pattern in, or at least I find it a fairly common pattern in APL. So thanks a lot for watching. As per usual, you can comment your alternative solutions or you can make pull requests or open issues, whatever you prefer, on the GitHub repo that I'm using to list all of the solutions that everyone shares. And other than that, I will see you in the next video. So bye.